Namaskar friends, welcome to session 49 of our course on work system design. We are currently trying to find out the standard time for performing the task, and prior to this we have had discussion for 4 weeks on method study. And if you remember, in method study we have found out one best method for performing that task. We have found out one best sequence of operations to perform that task. So already the way, the method, the technique by which the work has to be done is already known to us. Now we are trying to find out that how much time it will take for a skilled, experienced worker to do the task using the standard approach. And in that we are discussing the various tools and techniques of work measurement. And in work measurement, if you remember, we have already seen the stopwatch time study. We have seen the work sampling approach. Now our focus primarily is to understand that why do we need to do the study again and again? Why can't the things be referenced? Why can't there be a standard synthetic data through which we can do the calculations and find out how much time it will take to perform that task? For example, this is an example which I normally use in the class, that a hole has to be made in a 1 centimeter or 10 millimeter thick mild steel plate. So the problem is we have to make a hole in a plate which is made up of a material which is already known to us. Now we have to make a hole. If we divide this overall operation of hole making or drilling in a steel plate, we can divide it into the individual work elements, maybe fixing up of the job, switching on of the machine, bringing the the machine head down, performing the actual drilling operation, then moving the drill up, then removing the job from the work holding fixture, cleaning the machine. So these are the various work elements that will be used. Now suppose we do the time study using the stopwatch, and for each of the work element, for 3 or 5 different workers, we note down the readings using the stopwatch. Then maybe for each work element, for each worker we take around 5 to 10 readings, and for 5 different workers we take these readings, and then we average out. Then we multiply by the rating, multiply these with the rating factor. Finally, adding the allowances, we are able to find out a standard time for hole making in a steel plate of 10 millimeter thick. Only the diameter I have not specified. For example, it is a 10 millimeter diameter hole. The diameter is 10 millimeter, the thickness is 10 millimeter of the plate. Now suppose maybe after 6 months or after 1 year, I have to again find out the time required for making 20 mm hole, or for that matter maybe 5 mm hole. The diameter is 5 mm and the thickness is again in the same sheet, it is 10 mm. Why do I need to do the time study all over again, when already I have divided the overall operation into the individual elements, and for each element I have taken maybe 25 or 30 different readings, and for each work element I have averaged out the readings, I have multiplied it with the rating factor. Same workers are going to perform the task. Why do I need to do the time study again? Can't I document the data which I have done for 10 millimeter, diameter 10 millimeter, and use the work elements which are common in my time studied or stopwatch time studied data? So whatever elements are common, I can directly take the information from there, and whatever is uncommon, which is special, I can do the study only for that, and then I can combine the two and set the time standard. A very practical approach for setting the time standard for operations or work elements for which the data is already available. So if we have already available data, we can make use of that data, and that is the basic concept on which we are going to discuss today, the importance of the synthetic data and the PMTS. So the title of the course today we are going to discuss is Introduction to Synthetic Data and PMTS, Predetermined Motion Time Systems. So both these terms I have used numerous times in our discussion on work measurement. Today we are going to start this discussion, and maybe in the session number 50 our target will be to discuss the motion time measurement MTM system, which is one form of PMTS system. So today is the introductory part, and I think I have laid a good foundation for the discussion for today, that it is not always desirable to do the time study or work sampling again and again. So if we have the standard data available with us for the various work elements which are common in the different types of jobs, we can use the standard data and synthesize that data, add that data for the basic motions to find out the overall time standard for the particular job or the task or the group of tasks. So let us start our discussion with this background. Now let us see what is synthetic data, very important. Here we can see adding up of the dots has led to the depiction of a figure. Here also adding up of the dots. So here also the basic work motions, work elements we are going to identify in the job in which we are, for which we are going to set up the time standard, and then we are going to add up the elemental times for each and every element to synthesize it into a time standard. So what do we mean by synthetic data? So it is a work measurement, which is our broader topic. So synthetic data is a work measurement technique for building up. When we make a building, we make it brick by brick by brick by brick. So similarly, building up here means time, elemental time plus elemental time plus elemental time plus elemental time. Maybe for all the work elements we add the time and we get the total time for performing the task. So it is a work measurement technique for building up the time for a job or a pans of job at a defined level of performance. How? So this is a technique for finding out or calculating or synthesizing the time required for performing the job at a defined level of performance. How? By totaling element times obtained by totaling the element times. So we have to divide the overall work into the individual elements, and for each work element we have to look in the synthetic data the time that is already recorded for some other job which was time studied earlier, and the time elemental times are well documented. So from there we will take the time for the common elements. So once we are able to get the times for the various elements we will obtained previously from the time studies. So whatever time we get, what we will do, we will total them. So totaling the elemental times obtained previously from the time studies on other jobs containing the elements concerned or from the synthetic data. So basically what we are going to do, we are going to divide the overall work into the individual elements, and for each element we are going to look for the synthetic data available in the form of time estimates, and then in these individual time estimates we will add up and try to set up the standard time for the job in question. Now what are the steps involved in synthetic data? Collect all the details about the job, dimensions, tools, method, as I have given an example of the drilling operation. Analyze the job into constituents, elements. So whatever is the job, suppose this is the job, we have to divide it into the constituent elements. For example, the total job is divided into 4 elements, 4 basic work elements. Select the appropriate basic time from the synthetic data covering the contingent factor. So for all these 4 elements we have to find the basic times. Synthesize and apply synthetic data covering the contingent factor. So now this we have to first select the time for the individual element, then we have to add up these times to see or to synthesize these time to get the total time. Verify the details of elemental analysis for job method and condition. So we have to check that whatever total job has been divided into the element, different work elements, whether it is actually depicting the complete job profile or not, or something we are missing or something we are adding additionally which is not required in the job actually, or practically is not required in the job. Total the basic times which already has been said, rating and allowances to compute the standard time for the jobs. So the only thing here is that we are not going to actually or physically going to record the time or to time the worker or to observe the worker and then note down the time. We are also not going to do the work sampling where a time study analyst is going periodically or randomly to the shop floor to see whether the person is working or idle. Here we are going to use our previous data of elemental times to add up the elemental times for the job in question. Only those elemental times we will add for which we have the previous data available, and then we will try to synthesize the standard time for performing the task. Now what can be the advantages? You can very easily now infer the advantages. It can be used in place of time study to determine for many other types of work, which includes repetitive work, provided the necessary data is available. So repetitive work is there, in that case you can use the synthetic data. It reduces the cost of application of time study, so we need not have persons going and doing the recording for or recording of time for the various workers. So it is just maybe summation of the already available data to find out the standard time. By means of synthesis, it is possible to establish times which are equally satisfactory for planning and production control purposes. So why do we want to find the standard time for performing the task? In order for planning and for production control purposes. So whatever information we can derive from synthetic data can be equally useful as if we have done it manually or physically timing the worker or the work sampling approach. So if we do a stopwatch type of time study or we do a work sampling study or work sampling procedure to set the standard time, the synthetic data approach is equally profitable, is equally applicable for the planning and the production control purposes. Now the second approach is the predetermined motion time systems or the predetermined time standards. This we will try to understand. So there are different types of PMTS systems. We will try to just have a historical preview of all these types of systems, and then finally we will see that what is the basic behind predetermined motion time systems. So what do we mean by predetermined motion time systems? Synthetic data I think is clear to all of you. Now a predetermined time standard or the predetermined motion time standard is a work measurement technique. It is also a work measurement technique whereby times established for basic human motions, classified according to the nature of the motion and the conditions under which it is made. So the basic human motions or the times established for basic human motion are used to again build up the time for a job at a defined level of performance. So important point is that already there is time established for basic human motions. So there are maybe standard tables or values which are already available with us. So these values or the times established for basic human motions are used to synthesize or build up the standard time for performing a task or for performing a job at a defined level of performance. Each of these motions is assigned a previously established standard time value, previously established. In case of stopwatch time study, work sampling, we set the standard time, we find out, we calculate, we use statistics to calculate the standard time. But here we are using the time standards already established for previous jobs, and from there we are trying to deduce as much information as possible. But one thing we have to keep in mind, that our new job or the job for which we are trying to find out the standard time must have same work elements for which the time standards are already available. So that is an important prerequisite, because we have to first divide the job at hand into its different work elements, or as per this definition, into the basic human motions. So for these basic human motions the data is already available. So and that data is based on according to the nature of the motion and the conditions under which it is made. So we will see different types of examples for PMTS and try to understand that what do we mean by the nature of motion and what do we mean by the conditions under which it is made. So each of these basic human motions or basic human motions is assigned a previously established time standard value in such a way that the timings for the individual motions can be synthesized to obtain the total time for the performance of the activities. So we will build up, we will add up, we will synthesize all these basic work elements into the total time required for performing the job at the defined level of performance. Now these are the commonly used predetermined motion time systems. Very quickly, one slide or two slide each, we will try to cover these. Method time analysis, work factor system, methods time measurement, basic motion time. So let us see one by one. This MTM we are going to study in detail. Maybe we may cover this in the next session. So method time analysis, the historical perspective. A.B. Segur of Oak Park, Illinois was one of the first to establish the relationship between the time element and the motion itself. So there are two things, one is the basic motion and the another one is the time. So we have to divide the work into the basic motions, and for those motions we have to establish a time, that this is a time or the time element required to perform this basic motion. So Segur stated that the method must be well defined before an attempt is made to estimate the time standard for the motions involved in the work. So this is what I have been emphasizing in the beginning of almost all of my sessions. We have been saying this again and again, that we have already discussed the best techniques or the techniques which can be used to find out the best method for performing the task. Some of the graphical tools that we have already studied are the outline process chart, flow process chart, multi-activity chart, two-handed process chart, CMO chart, principles of motion economy also we have studied, Therbligs we have studied. So we now know that what can be the techniques which can help us to find out the best method for performing that task. What is the best method? All of you know. Now once the method is established, then we have to focus our attention on finding out the time required for performing the task. So he developed a table of improvement principles involving many of his basic motions such as hold, grasp, preposition, position, avoidable delay, balance delay. So these are the basic motions. So these basic motions were involved in dividing the total work into the individual motions, and for each motion then there can be a time estimate which can be added up depending upon the types of motions coming into picture for the specific job. It may not happen that all the principles or all the basic motions are being used for a particular job. Whatever is used, it will be selected, time will be noted down, and it will be synthesized or built up. So a table of improvement principles involving many basic motions were developed by him. The improvement principle involved here is in the elimination of the left hand as a holding device. So this is the improvement principle which is very specific to method time analysis. In MTA, motion values are given up to 5th decimal place. So this is the historical perspective of MTA. Then the work factor system. This is a system of PMTS in which it is possible to determine the work factor time for manual tasks. Again, the manual tasks, the work has to be divided into manual tasks by the use of predetermined data. So the basic principle remains the same, that we have some historical or some previous data, pre-established data available with us, and we have to correlate the job for which we are performing the work measurement, and we have to divide the job into the individual elements and then look for the data available and then find out the data and synthesize it into the standard data. So a detailed analysis of each of the tasks is made based upon the identification of major variables of work and the use of work factor as a unit of measure. Then the standard time from the table of motion value is applied to each motion. So the language may change, but the theory behind the principle remains same. Now work factor system, 4 major variables of work factor system are body member, distance travelled, manual control, weight or resistance. Maybe suppose I am moving with holding a weight for maybe 2 meters distance, so the weight is also coming into picture as a factor, the distance of 2 meters is also coming into picture. So that will be accounted for when we will look for the standards, and accordingly we will add up these standards to find out the standard time for performing the task. This system is applicable to highly repetitive work. So the important factors need to be understood: the body member, the distance, the manual control, and the weight or resistance. Now basic motion time study, third type of PMTS system. Basic motion time was developed by JP Woods and Gordon Limited in Toronto, Canada. According to Woods and Gordon, it is defined as any motion which starts from rest. So the initial state is rest state, moves through the space, that is the motion, and ends at rest. So that is, they have defined the motion as. Now different types are: type 1 reach. For example, this pointer is kept here, I am standing here, I am in a state of rest. So first can be I reach to this place, I go and pick it up. The second, type 2 is move, I have moved. Then type 3 can be turn. The body motion and symbols are very similar to the body motions employed by MTM, and the only difference lies in the step where the distance measured is the distance the foot travels. So maybe the MTM classification or the motions is more or less similar to the basic motion time study. So we are going to study MTM in much more detail. We will have one complete session on MTM, but this is the historical perspective of PMTS systems or various types of PMTS systems. So the overall summary of PMTS is that yes, there is standard data available, or there is the time estimates available for the various basic motions, and we can divide the work into the various basic motions to find out the standard time for the job. Now let us see the predetermined motion time systems. Basic. What are the basics? So the components of basic PMTS system are given here: the motions, reach, the description is given, move hand to the destination, grasp, secure control of the job object with fingers, move the object, position, line up and engage object, release, let the object go, body motion, leg trunk movements. So these are various basic motions, and this is the description given for them. Now what we need to keep in mind? We need to keep in mind that whatever work we want to find out the time estimate for, or for the work for which we want to find out the time estimate or standard time, we have to divide that work into the individual motions, and for these motions we have to take into account other factors also, like the distance moved, the steps moved. Suppose somebody has to bring a material or a job from the first floor, so the person will move for a particular distance, then he will climb up the stairs, then he'll go to the shop, maybe he'll move certain steps in that movement also, then he will locate from where the job is lying, then he will pick up the job. The job may be heavy, it may be 10 kg, 15 kg of weight. He has to bring down the job from the steps and come back to the place from where he started. So the same, one of the principles we have seen, he is in a state of rest, then he moves, then he comes back to the state of rest. So all this total work is divided into the individual elements or the motions, and for each motion then we will have to look for the time estimates, and based on the times we will calculate the total time required for performing this task. And these are some of the motions given on your screen. Now there are different forms of PMTS systems. This is the first level MTM1. So here we use basic motions like release, reach, grasp, move, position, release. In the second level of MTM2 we use, or the second level we use get, which can be a combination of release, reach and grasp, and then put, which can be a combination of move and position. So in put, we can say put this thing here. Another can be move first and then position it at this place. So move plus position in MTM2 we can say it put, and the third level we can say handle. So handle means get and put. So I am getting it and then I am positioning it. So it is handling, I am handling this particular pen. So maybe different levels of MTM. So the basic body motions, the basic motions are divided into different levels or different levels of micro analysis or different levels of micro motions. And if you remember, we have already seen in method study the principle of Therbalix. So we at one point of time focusing on the basic motions of the human body. At the other end or the higher level of analysis, we are developing an outline process chart where we are focused on the overall industry in totality or as a whole. So we have different levels of analysis. We can have analysis at the system level, we can have analysis at the man machine interaction level, or we can have the analysis at the man or the basic hand movements or basic foot movements or the basic eyeball movements of a worker who is performing the task. So the level of analysis keep on changing, and this MTM2 also, MTM3 also, MTM4 also, higher level MTM5 is given. So maybe different levels are there. So it is for us to decide that at what level of our basic motions we want to go and find out the time required for performing the task. Now factors for selecting the predetermined motion time system. So these are some of the important factors which will be considered while selecting the PMTS system for application to particular industry. So we have seen that there are MTM 1, 2, maybe depending upon the level of analysis we can have different systems. So how to decide which one to use? One, I have already told you that depending upon the level of our analysis we can decide which one is suiting to our requirement. But then there are other factors also: cost of installation, application cost. Application cost means when we are trying to find out the standard, we may need to hire the expertise of a consultant. So that can be one of the cost involved in the whole process. Nature of operation, as I have already highlighted, that depending upon the nature of work being done in our organization or the industry or on the shop floor, we have to take a call that at what level we want to do the calculation. Performance level of the system, that we have to also take into account, because the performance level at which the system that we are using or the already existing data has been recorded or has been documented, whether our system is able to match up to that performance level or not, has to be taken into account. Then consistency of standards is another parameter which must be taken into account, that whatever standards are followed in the industry where this system was developed, or where in our industry only, whether we are able to consistently follow those standards for which the previous data or the data which we are using for building up our time was developed. So that consistency of standards also has to be kept in mind. Now this is an example: assembly works in or assembly work in the electronic industry is most common example of PMTS system, because you see the same type of repetitive work is being done. So even if there is small change in the operation, we need not do the time study again. We can look for the basic motions and then try to find out what are the additional motions being done. Try to look for the time estimates and add up the time estimates to get the new time standard. What are the applications of PMTS? It can help us in the determination of time standards. I have been highlighting this all through today. Comparing the times for the alternative proposed method so as to find the economics of the proposals prior to production run. So we may have 3 or 4 different proposed methods. So we want to find out that method which will be accomplishing the work in the minimum possible time. So the time standards or PMTS system can help us to select the best proposal out of the alternative proposal methods. This is a very common advantage or application of work measurement technique, that we can do the estimation of manpower, estimation of equipment, space requirements prior to setting up the facilities and start of production. So once we know how much time will be required by a able-bodied person to perform a specific task using a standard method, we can very easily do the calculation for the manpower requirement, the equipment requirement, the space requirement, as well as other decisions related to managerial activities. Developing tentative work layouts for assembly line prior to their working. So that can be also be seen, that if we have to, for example, make assembly line, the movement of the job on the assembly line can easily be controlled if we are able to find out that how much time a worker will take in performing a specific task, and then checking the direct time study results. So we can also find out that what improvements have been noticed after the finding out of the standard time. Now, what are the advantages of PMTS system? Short cycle jobs can be timed accurately. Rating, the most difficult part of the time study is not necessary here. We have to find out the times for the various basic motions and then add them to calculate the standard time. So there is no need to multiply the observed time with the performance rating factor, or in work sampling also we use the rating, which is not required in PMTS system. The results obtained are consistent. A reasonable estimate of the work content can be obtained before the task is actually carried out. So here we can synthesize based on the already available information. What we can synthesize? The time data. Whereas in case of stopwatch time study or work sampling, the work might be in, or work has to be in performance, or the work has to be being done, or the work has to be in action, because we have to record our data based on the action of the work. But here that action is missing, that action is not required. We have the data, or we have the information. Based on that information, based on our common sense of the work being done, dividing that work into the individual constituents, we can synthesize the time standard before the work actually being done on the shop floor. So that is another advantage of PMTS system. So that's all regarding the PMTS system as well as the use of synthetic data. In the next session, our target will be to understand the MTM system, which is one of the important types of PMTS systems. Thank you.